All right, let's look at implicit differentiation. And it's probably the easiest to dive right into an example. So let's do that. All right, let's say you have a circle centered at the origin with radius 5. So equation is x squared plus y squared equals 5 squares, right? Let's say we want to find the slope of the tangent line to the circle at the point 3, 4, right? So we already drew the picture, right? So I'm going to do it in two different ways. One is the old way, explicit differentiation, and the new way is implicit differentiation, right? So let's do that. All right, so starting with the circle, right? Equation of the circle is x squared plus y squared is equal to 5 squared, right? When you have an equation like that, we need to rewrite it as y equals form, so for explicit differentiation, so that we can take the derivative. All right, so let's do that. So first, we're gonna have to move x squared. So I'm gonna put the x squared over to the other side. So we can do that by simply subtracting x squared from both sides. All right, so you have a y squared is equal to 5 squared minus x squared, right? Then after that, we have to get rid of squared here, right, to isolate y. So if you take the square root, you're going to get y is equal to, right, so whenever you take the square root, you have to be careful because we have to consider the positive version and the negative version. So you have a plus or minus square root of 5 squared minus x squared, right? The reason why we have two positive 1 and the negative 1 is that the top semicircle has the equation. So the top equation, so here, the top one has the equation y equals positive square root of 5 squared minus x squared, right? And then we combine that with the bottom circle to make a whole circle. Y equals negative square root of 5 squared minus x squared, right? In this particular problem, the point of tangency is located at the top semicircle. So we're going to use the top one, right? So we can kind of ignore the other one, right? So we're gonna keep the top one, so the positive one, right? So we have that. All right, so we have, so I'm gonna write the y equals, right? When you take the derivative, square root, I don't like square root, so I'm gonna rewrite it as a quantity of 5 squared minus x squared, raise it to the 1/2 power, because that's equivalent to square root. All right, so let's take the derivative in the regular way. So if you take the derivative, dy over dx, or you can write it as y prime, same thing. All right, so we're going to put the 1/2 in front. All right, then inside stays the same. So you have a 5 squared minus x squared stays the same. And since it's a power rule, subtract 1 from 1/2. It's going to be negative 1/2. But because of the chain rule, multiply by derivative of inside. So derivative of 5 squared is 0, since it's a number. Derivative of negative y squared would be negative 2x. So we got that, right? Then we can clean it up. You have 2 on the bottom, and then there's a 2 on top. And that's pretty much all you can do. All right, so this is going to be equal to, right? So there's a negative sign here. So I'm going to put the negative sign in front. And looks like x lives upstairs. So here x, I'm going to put the x on top. All right, and then because of the negative power, I want a different color there. Negative power, we know that 5 squared minus x squared has to be on the bottom. So you have x squared, 5 squared minus x squared, right? Then we still have to take care of 1/2 power, which is equivalent to square root, right? So we got that. All right, then if you want to evaluate it at the x equals 3, so that's comes from that's given, x equals 3. So you have so this is the same thing as y prime. Maybe this might be an easier notation. All right, so if you want to find the slope, all you have to do is look at the derivative and plugging in the x coordinate, which is 3 in this case. So you have negative. All right, you put the 3 on top and then square root of. All right, so you have a 5 squared is 25 minus 3 squared is 9. So 25 minus 9 is 16. So which is, oh, actually, can I just go ahead and take a square root of 16, which is 4. All right, so you can see that we have the slope came out to be negative 3/4. All right, so that's the kind of the old way. So this is the, let's see, I'm going to, so this is the old way, all right? And here's the new way, which is called implicit differentiation as opposed to explicit differentiation. So this is the new way. All right, so the benefit of this is that you don't have to solve for y. We can just go ahead and take the derivative directly from the given equation. So what happens is that you have x squared plus y squared is equal to 5. What you do is you take the derivative with respect to x of both sides. So you take the derivative of the left-hand side, take the derivative of the right-hand side, right? So this comes out to be, right, we know how to do it, right? So derivative of x squared would be 2x, because it's we're talking about using the same variables here, right? And here you have y squared, so with respect to x, so it's going to be 2y, but you have to multiply by derivative of y with respect to x. Right, so that would be the derivative of the left-hand side. The right-hand side, the derivative is going to be derivative, oh, actually, sorry, this is 5 squared. Derivative of that would be 0 anyway. Right, so we have that. All right, since we're interested in the slope, what we're looking for is actually this guy right here. dy over dx, it contains the information about the slope, right? So we're going to have to solve for this, right? So first, I'm going to shove this guy over to the other side. So 2x sent over to the other side. So I'm going to subtract 2x. So you have a 2y dy over dx. And sitting on the left, and you have a minus 2x on the right now. All right, now we're trying to get rid of 2y, so easy way to do that is divide through by 2y. So we have a dy over dx all by itself, which is what we wanted. And you have a negative 2x is divided by 2y. All right. We can cancel out the 2 on top and 2 on the bottom. So it came out to be negative x over y. All right. So if you want to find the slope m, I'm going to line them up. All right, all you have to do is look at the derivative, dy over dx. Then we know that the point of tangency is 3, 4. So we plug in 3 for x and 4 for y. Then you get, so you have a negative, right? X is 3 and y is 4. Right? So we got the slope of the tangent line using implicit differentiation. Right? So you can see that here you are actually getting exactly the same answer here. Right? Right, so this new method is called the implicit differentiation, and the old method nobody really calls it, but you can probably call it explicit differentiation as opposed to implicit differentiation. All right, that's it. I hope that this was clear.